So we're going to talk about polynomial functions in modeling. So the objectives is to determine the behavior of a graph of polynomial function using the leading term test. We're going to factor polynomial functions and find the zeros and their multiplicities. We're going to use a graphing calculator to graph the polynomial function and find its real number zeros, its relative maximum and min values, and its domain and range. We're going to solve the applied problems using polynomial models, fit, linear, quadratic, power, cubic, and quadratic polynomial functions. So a polynomial function, in this case here, we're going to use, as you can see right here, let me get my pen going, this P that we got here. We're going to use it and let it be the name of this function. We're going to call it P, and we're using it because we're going to let it represent polynomial. And this function, P, the name of it, is in respect to X. So we got to equal to all this going on. And if you'll notice, it's written in descending order. What is descending order? It's the highest power. So if this was a 7, then it would go 7, 6, 5, 4, 3, 2, so on. So A to the nth, or subscript n, excuse me, A to subscript n is a coefficient. So it could be like 1, 2, 3 negatives numbers. X to the n power here is going to be my variable part of this. And n is going to represent the leading power. We're going to add plus or minus another coefficient times the x raised to n minus 1. So if this was if the first was n to the 7th, then the second be n to the 6th. And so on. It's going to go all the way down till we see A, the coefficient has a subscript of 0. What does that mean? What does these subscripts mean? Let me change my pen real quick. This means that this coefficient here, subscript n, goes with this variable term because it's multiplied to the variable term. It's the coefficient on it. This one here is a to the 0, meaning it has no variable term on it. Why does it not? Because if I put x raised to the 0 power, we know that's 1 times a to the 0. So this is just letting you know this coefficient has the no variable showing because it is really 1, because x or any variable raised to 0 is just 1. The only thing that doesn't apply to that rule is the actual number 0. Now, all my a's here, like it states in the sentence form, is real, and there are my coefficients, and the numbers or exponents are whole numbers. So these variable terms with the exponents are going to be whole numbers, the powers. All right, so now we have a function here. It's called f in respect to x. And you're given x squared minus 2x minus 3. Well, we know we can factor it down. And when I factor it down, I'm going to get x plus 1 times x minus 3. And I want to do a really quick review on how they factor it for those of you that don't understand where they came up with the factoring of it. Okay, so if I took x squared minus 2x minus 3, I'm going to use the AC method. And what is the AC method? Well, I know it's written as ax squared plus or minus bx plus or minus c. So what is c and a? A is right here. It's positive 1 because we don't see nothing. And c is negative 3. So when I multiply these together, I get what? Negative 3. So I'm going to take the product. And I'm going to subtract. How do I know that I'm going to subtract? Because if you look at the sign on C, that tells me if I add or subtract. So this sign here on C is a minus. So it tells me I'm going to subtract, right? And then what am I subtracting? I'm subtracting the product of A times C. That will give me B. And B is negative 2. So let's do that. So I'm subtracting the product. And what is A times C? It's going to be 3. And I know I said -3, but the negative went with C and it told us that we're subtracting. Well, 3 is prime, so I know it's just 3 times 1. And I need a -2 for B. I need it. So that means it's going to be 1 minus 3 because 1 minus 3 gives me the -2. So now I have my new middle term. So I'm going to rewrite it. What I'm going to do is, let me clean this up just a little bit, some notation. I'm going to bring down the first, which is x squared, and bring down the last. And let's rewrite the middle term. So let me change this. So I got +1, and remember the middle has an x on it, so I'm going to say a +1 times x, and then I have -3 times x. All right, now that I've done that, I'm going to split it in half. You see that we got 4 terms, right? So let's split it in half. Whoops, I didn't mean to go through the negative sign. So I split it in half, and I'm going to factor out the GCF on this side here. Well, when I do that, I see that I can factor out an x. And when I do factor out an x, it's the same as saying divide each part by x. That leaves me with x plus 1. I'm going to bring this negative sign down. And what is the other GCF part? It's a 3. So I'm going to bring out the 3. That means I'm going to divide by -3. When I divide negative by negative is positive. 3 goes into 3 once. 1 times x. Negative divided by negative is positive. 3 goes into 3 once. So now I got +1. So now I'm going to factor out the GCF. You notice that what do we got going on here? We have a monomial times a binomial minus this monomial times this binomial. So what I'm going to do is I notice the parentheses are identical. So let's factor out the parentheses. I have x plus 1. And when I factor that out, it leaves me with x minus 3. And that's how they got that. So that's for those who did not understand where that came about. Now, what we're going to find the zeros. How do we find the zeros here? Well, I'm going to take my factored form here, x plus 1, set it equal to 0, and x minus 3, set it equal to 0. You can drop the parentheses. I just brought it over there so you can see that, it didn't change. I'm going to subtract the 1 from both sides, and it gives me x equals -1. I'm going to add the 3 to both sides, and that gives me x equals 3. So there's my zeros. What does that tell me? That tells me that at -1, when x is -1, I get a 0 value for my y, and it crosses the x-axis right here, you see it? And then when I get x equals to 3, I get a 0 for y. So here we go, we get our zeros. And also, that gave me my x-intercepts. So if you notice, our order pairs is x comma y, right? And y is 0 when x is -1, y is 0 when x is 3. So there's my x-intercept. What about y-intercept? We don't know what y-intercept is. So I'm going to clean this mess on my screen real quick. So if you need to write this down, I would encourage you to, rewind a little bit and pause it and write everything down. I'm going to clean this up so we can do the next part. Okay, that gives me a little bit more room. Now, some of you will use the quadratic formula to factor, and that's okay too, but you do need to understand where it came from. You don't need to just rely on it all the time, because you need to understand the math behind it as well. So now let's figure out where this apologies. Let me give me my pen back. There we go. Where it crosses, where this quadratic crosses the y-axis. I know it gave it to you here, but we need to figure out how to solve for it. So in order to figure out what the y-intercept is, I know x is going to be 0. I know that. So what I'm going to do is take this function, and everywhere as I see x, I'm going to plug in 0. And what happens? 0 squared is 0. -2 times 0 is 0. Leaves me with -3. So that's how we got our order pair, 0, -3. You come over here and plot it right there. And now we're going to state our minimum and maximums. All right. So when we graph this, I want to go over the minimum maximum right quick. But before I do that, let's talk about how I know what's happening. We come over here and we look at what our coefficient is right here on this x squared. And if it is a positive number, if it's positive, then the parabola opens upward, giving me a minimum. If it's a negative number, it opens downward, giving me a negative, which is a maximum, right? So right here is our minimum, and you can figure it out by coming over here and plotting it. Another way is to find the vertex, right? So first things first, we needed to determine if it's a minimum or max. And since it was a positive value, I knew it's going to open upward, give me a minimum. So I'm going to say none to the max because, it's not going to open up downward, right? So let's find where it actually occurs at. And I know some of you are going to use your calculator, but there's going to be a moment that you need to be able to determine where it happens at without relying solely on your calculator. So I just want to show it to you. So I'm going to find the vertex. To do that, I know that it's going to be negative b over 2a, comma, the function of that. So another way of stating what the vertex is, we know it's x, comma, y, but the vertex is labeled h, comma, k. All right, so let's do that. Because h is actually negative b over 2a. What is negative b? Well, negative b is negative times negative 2, and a is just positive 1. So now I'm going to clean this up. Negative times negative is positive. 2 times 1. This reduces down to 1. And my x value in the order pair is 1. So now I have this. Now let's find k. K is going to be that we're going to plug in 1, that function, and 1 for x in the function. Let's do that. So now I got 1 squared is just 1. I'm going to erase something right quick. It's just in my way. Okay. It's 1. Negative 2 times 1 is negative 2 minus 3. All right, so I got 1 minus 2, which gives me negative 1, minus 3 gives me negative 4. So that's where they got the y value of 4, and it occurs at 1, comma, negative 4. So when I come up here, there's my order pair for that. I do see a notation error right here. I erased it. Okay. So now we graphed it, we plotted it, we stated it. Let's talk about the domain and range. So our domain is going to be my x values, right? And when we read it, we read left to right. The reason why we read left to right is because the smaller number is listed first. So let's do that. When I start right here, it's negative infinity, and I'm reading to this direction. And what do I see? I see that I have a arrow pointing up. That means it's going to continuously go like this. So I have a negative infinity. And I keep reading and I go across and I see this arrow here and it's going to go off like in that direction. So I have a positive infinity. So my domain's all real numbers because the arrows tell me that it's going to just eat up all the x values. Now let's talk about the range. The range is my y value. So we always start at the bottom and we read up to the positive. Well, what happens? I got to where y is negative 4, and I notice this is where it actually, there's no arrow there. It's actually sitting there. So I use the bracket here at negative 4. And then I'm going to keep going up, and all I need is an arrow on one of these lines. It don't have to be on both, just one of them, because it tells me, the arrow tells me it's going to continue to go up. That means it's going to eat all the positive values for infinity. So I know, or for the y value. So I know that my y value is infinity. So that is my range. Oh, and I want to tell you right quick, if you notice the parentheses here on the infinity, it's a parenthesis, not a bracket. That's because you can't stop infinity. That means that we're approaching it. You know, we're approaching some point, and we're just continuously approaching it. This bracket says we literally stopped on -4, or we literally are sitting there starting on -4. So we can do that because it has some value where infinity is continuously going on. So this next function here, as you can see here, it was, they found the real zeros here by doing the factoring form. You can do factoring form by using synthetic division to break it down that way. I'm going to go over that in a separate video. We can do that by graphing this function. And when you graph this function, you'll find all the areas that it crosses the x-axis, and then that's where you know your zeros are at. And then you can read and write it as your x-intercept. There's multiple ways of doing this. So please see my video on how to type in your answers in the graphing calculator online. If you need help with the regular one, just holler at me. All right. So now our y-intercept, again, you just plug in 0 everywhere you see x, and then we know where our y-intercept, where it crosses the y-axis. Now, this one here has a lot going on. So we have a cube root. It's not a simple, it opens upward or downward, and we know it has a minimum or maximum. So what we're going to have to do is actually find those specific points. And when you go to the graph, you know, you see this spot right here. Here, let me highlight it so you can see what I'm doing. This spot right here and this spot right here tells me. This one here tells me the max, and this one here tells me the min. And if you would like to see more information on how to calculate it by hand, just holler at me. All right. Then our domain, again, we're going to read left to right. And as you notice, we have arrows both left to right, so it's all real numbers. So when I read the range, I go from the bottom to the top, and I notice there's an arrow pointing down and an arrow pointing up, so it's all real numbers. So these are examples of what you're looking at if you are looking at as far as graphing goes. So let me change this right quick. If you notice, this is a polynomial with a leading degree. What's the degree? It's that leading power right here, this power of 2. So it tells me I have a parabola, and since x is positive, I know that it opens upward, giving me a minimum. And y'all, that was terrible on the shading. There we go. And then this next one says I have f of x, this polynomial function. And poly, what does poly mean? Means many. So we have a monomial, which is one term. We have a binomial, which is 2 terms. We have a trinomial, which is 3 terms. And we have a poly, which means more than 3. Okay, so the second one here is a straight line. And how do I know that? It's because the leading degree is 1 or less. And if you see no x value, then the leading degree is 0, right? So we have a horizontal line. If the leading degree was 1, we may have a line that goes like that or like that. All right. But if it's a leading degree of 0, then I know it's a horizontal line. The polynomial function, we have a lot going on. So most of the time you see this going on, or you may see the one that we did before this one. This one is a binomial. So we have this going on. What happened to x squared and the x to the first and then the constant? The constant, this is a constant. It's a constant because the x is 0. power on it. Well, they all have, they don't exist. They have a 0 power, but yet there is something going on, right? It's not just a complete, it doesn't look like example 1 because example 1's a quadratic, where example 4 is raised to the 4th power. All right, so now when we start talking about absolute values, we're going to get the sharp look about it. The sharp looks like a check mark. Sometimes it looks like a V. So if this absolute value has a negative sign in front of it, it would be flipped about the x-axis, so it'll be pointing down. Then if we have a square root, then we have this look about it. And then whatever changes go on around it will determine if this flips the other way or upside down. This -1 on the outside of the square root tells me that my y is going to be -1. This +1 in here, that means we got to solve for it. It's going to tell me that I'm going to end up at -1 for x. But if you need me to break this down, just let me know. This one here, I have x to raise to some power, so we get this look going on about it. And then I have this rational function. And then we are able to graph it. And we're going to go over how to graph these things later. So the graph of a polynomial function is combined or is continuous. My apologies. Let me reread this. The graph of a polynomial function is continuous. That is, it has no holes or breaks. So it's a smooth transition. So you notice, let me go back to this one. It's just a smooth transition. So there's no breaks in it. The one before this slide had no breaks in it. It is also smooth. There are no sharp corners. Furthermore, the domain of a polynomial function is the set of all real numbers. The range, though, however, can be something different. Most times, all real numbers. Now, this here, I would encourage you to have this on a flashcard, or on a notes, or on somewhere separate. Whenever you're trying to graph a polynomial function, there's so much going on, right? Well, our leading coefficient is attached to our leading. Well, let me say this better. If I have everything written in descending order, meaning that the highest power, so if it's 7, x to the 7th, ... x to the 0, which gave me my constant of just a to the 0, right? All right. So we will take this one here. It has a leading coefficient with a leading degree. We're going to take this and look at it. If the n, which here is my leading degree, right? If n and, okay, so let me backtrack. My leading degree, right, is on my variable term. However, the coefficient on the leading variable, there we go, is a to the n. If that number there, or that value, is greater than 0, we're going to, and it's even, we're going to open on both sides, or go up on both sides, right? There's going to be a mess going on in the middle, but it's going to go up on both sides. If that a is greater than 0, but it's odd, then it's going to have this increasing effect from left to right. Something going on in the middle. If my a, this leading coefficient here, is less than 0, but it's even, then it's going to be flipped, right? And both those sides are going to go down and something going on in the middle. If it's odd, then it's going to decrease from left to right, which makes sense. So I encourage you to have this with you. So what I want to do is, using the leading term, we're going to match this to the graph that best represents it, okay? And unfortunately, the graph is, my apology, it's going to be labeled here. So let's match it. So we have it written in descending order. This one here, A, is written in descending order with a leading degree of 4. So my leading coefficient is 3. So it's odd and it's positive. So let's go back here. Odd, but greater than 0. If it's less than 0, we know it's a negative number, okay? If it's greater than 0, we know it's a positive number. This one's odd, and it's greater than 0. So that means it's positive. So we know we're going to have an increasing effect. So we're going to have, so A here is correct because we have this increasing effect going on. We're increasing from left to right. All right, now B says we have a -5, so we have a negative odd value. It is written in descending order. I should have checked that first. Yes, check descending order. My leading degree is 3. Okay, so we're checking out the -5. The -5 is less than 0, and it's odd, so I'm going to have a decreasing effect from left to right. So my decreasing left to right we agree is B, right? All right, now let's look at C. C has a leading degree of 5, a positive 1, so it's odd and it is positive. So we're going to have this effect going on. Let's come back here, guys. Oh, they're calling it even. They're calling 1 as even. So that's kind of odd for that, but we're calling the even. So we're going down on both. So that one would be C. And then, oh, no. I'm actually going to say D is C because 1, it's negative, right? My power is, my N is even. My N here is odd. My N here is even. Okay. And so my apologies, guys. Let's backtrack just 1 second. So my apologies. We are looking at the A value, all right? We are looking at the A value, and we are determining if A is positive or negative, okay? So if we're looking at if A is positive or negative, then we need to look at if N is even or odd, right? So let's go back and redo this one. My apologies. So on this one here, let me get this all cleaned up. Now A, oh, my apologies, guys. All right, so on A here, it is an even N value with an odd or a positive A value. Okay, we'll get this right. So we have a positive A value with an even N value. This tells me it opens upward on both ends, something going on in the middle. So my A here is going to be D. All right. My N is odd and my A is negative. Let's go back. N is odd, A is negative. So we're going to have a decreasing from left to right. All right, so let's go there and pick that one. Decreasing left to right would be B. That worked out. It's still stuck with it, right? C says our N is odd and our A is positive. N is odd. N is odd. A is positive. So we're going to have this increasing effect going on. And that's going to be A. Okay, increasing. And we read left to right. That's how I know. N is even for B or part D, and A is negative. So n is even. A is negative. So we're going to have this both sides going down. So C is D. Okay, so we have to take it slow. You see how easy it was for me to make that little topo there. And the reason why I didn't redo the video is because I wanted you to see how easy it is to make that mistake. However, just take it step by step. Don't get in a hurry. It'll get to you. Or you'll get it, figure it out. Just make sure and have, I would have that one thing written down separate, have it pulled to the side. This here is just telling us, let me get my pen back. Here we go. This table here is telling us solutions. So if you notice here is leading term, degree of the leading term, the sign of the leading term, and graph. So this was explaining how I got the answer from the last one. The leading term for A was 3x to the 4th. The n value, which is 4 here, is even, and the A is positive. So it was graph D. The leading term for B is -5 cubed, and the n value is 3, so it was odd, and A was negative, so it was graph B. Leading term for C is x to the 5th, n is 5, which is odd, and A is positive, so we picked graph A. D, the leading term is -x to the 6th, and n is 6, which is even. My A is negative, so we picked graph C. So now let's move on to our next one. Okay. Okay, so if C is a real number of a function, that is, if I have f of C is equal to 0, then we know C, comma 0 is an x-intercept, right? How do I know that? Because I know y is equal to f of x. F of x is a name of the function. It's called f in respect to x. So if I plug in 0, or if I said f of x equals 0, I'm saying y equals 0. If I said f of c equals 0, I'm still saying y equals 0. That's how we get this order pair of C0. All right, so finding all the zeros here in this one, we have this function going on, right? 1 second, let's get it pulled up. I was going to get a sheet pulled up, but I guess we'll just write on this one here. My apologies, guys. So, okay, so finding the zeros on this one here, you're already given to you in factored form, right? I noticed there's 1, 2, 3 of the same parentheses, so it can be rewritten like this. So what we're going to do is take each part and set it equal to 0. Well, 5 equals 0 don't give me anything to work with. It's not true. But x minus 2, I can set it equal to 0. And x plus 1, I can set it equal to 0 and solve. And then I get x equals 2. And then I get x equals -1. So these are my zeros. However, this cube is telling me that I got something going on at where x equals 2. And notice that it's kind of wild looking. All right, this next slide is just explaining to you that if x minus c raised to k, and k is greater than or equal to 1, so it cannot be 0 and it cannot be a negative number. It's a factor of a polynomial function. And then we're going to get this here. X minus c raised to k plus 1 is not a factor, or excuse me, my apologies. This is a factor of a polynomial function, p of x. But, and if we get this, then it's not a factor. Okay, K is odd, then the graph crosses the x-axis. If K is even, then it's a tangent to the x-axis. And tangent means that it might, so we have this line, we have some kind of point that's tangent to it. Somewhere it's kind of like not crossing it, but tangent to it. Let me see if I could draw something better. I'm gonna draw a circle. Sometimes it's easier for me to show you the tangent of it. Right here is the tangent of it. Okay. So we're gonna find the zeros of this function, this polynomial here. In order to do that, I'm going to factor it. So you can use the synthetic division to factor. And I notice, I keep saying synthetic division. That would be if we had some value and you would have to guess. You have to start off guessing those values. One would be, what if I said I plugged in 0 for x, I'm going to get a y-intercept. So that's not exactly what we're looking for. Another way to factor it is you could use, let's talk about this right quick. I was trying to find an easier way to make this make better sense. We can do this. We can split it in half and just focus on one half of it. There's multiple ways to do this. I was just trying to find an easier way to get to that point. So I noticed that on this side here, I got a GCF of x squared. So let's factor the x squared out. And when I do that, it means I'm dividing by x squared. So x squared pulls out of x cubed, leaving with x. X squared divided into negative 2x squared gives me a negative, not a positive. Let me erase that right quick. All right. A negative 2. Let's bring down this negative sign, and also notice that I can factor out a 9. So I'm going to divide by negative 9. So that negative 9 divided by negative 9x leaves me with x. Negative goes with positive negative. 9 goes with 18/2. That worked out great. Now I notice I have 2 of the same parentheses, so let's pull that out. And that leaves me with x squared minus 9. Well, x squared minus 9 can be rewritten as where I put the x in the beginning of each parentheses. And since it's a minus, we're going to have a difference. And then I know 3 times 3 is 9. However, if it was x squared plus 9, we could not do this. Okay. So now I have x minus 2. And I didn't mean to put square on there. I hope you caught that. I just got carried away. I factored it out. That's the same as dividing both parts by that parentheses because I factored it out. That was my GCF for this next row. All right, so now I have this. So now I'm going to find my real zeros by setting each part equal to 0 and solve. And when I do that, I get x is equal to 2 or negative 2. Actually, it's positive 2, and negative 3, and then a positive 3. Of course, you wouldn't write the positive sign. Okay. All right, this next slide shows you how to do, how to factor it. So this one here was a little bit more work. What I knew is that x to the 4th is even. And I know 2 plus 2 is 4. So I know that I can lead off each parenthesis with x squared. And then this says I'm going to take a product of 45 that subtracts to give me 4, a positive 4. Well, I know that 45 is 9 times 5. So if I subtract them, I need a positive 4. Then I know that 9 minus 5. So there, I plugged them in here. Now let's find our real zeros. So we took the x plus 9, or x squared plus 9, put it over here, set it equals 0, and then here's the x squared minus 5. I'm going to add the 5 to both sides. And then to undo the square, we took the square root of both sides. That made it 2 over 2. This is power over root, right? And whenever we take the square root of this other side, it's an even root, so we have a plus or minus. All right, over here, we subtracted the 9 because it was a plus 9 there. And then I'm going to square root both sides. We get a plus or minus, but we can rewrite this as -1 times 9. Well, square root of -1 is I, it's imaginary. Square root of 9 is 3. This here. All right. Next example is just talking about how to use graphing calculator to get these values and these points. If you have any questions, please feel free to see my video over how to use a graphing calculator and reach back out to me. This one here, you can use a graphing calculator as well. What they did is they put in 0 in that function for x and got 0, plugged in this for x and got this for y, this for x. So remember, this is y equals this number, and then in this parentheses here is x. Okay, so let's just plug it in. I'll let you read over this, and that was it.